All right, so let's just start out remembering how to do our factoring with a leading coefficient of 1. So let's see if I can make this bigger so it's more easily seen. All right, so again, what they want you to do with this is they want you to factor it into two binomials. So what I normally do is I, right off the bat, let's see, I do the two sets of parentheses. We're multiplying these two binomial or linear equations together that would multiply together to give you that. Since there's a leading coefficient of 1 here, we know that the leading one is an m. And now you just got to find two numbers that multiply to give you 20. But add to give you 12. So can you come up with those two numbers, Brock? Okay, so what'd you get? Very good. So you do an m plus 2 and an m plus 10. And again, it really doesn't matter which one you do first. So when I would go over here, you know, there's no reason I couldn't do the plus 10 first, because the order of multiplication doesn't matter, and do the m plus 2 second. And then submit, and great job, we got it right. All right, so I'm gonna skip ahead a little bit till we get to one that might be a little bit, like this minus sign. So let's do this one. So again, our variable's g. Again, we still have that leading coefficient of 1. So you're going to do two sets of parentheses. We're multiplying together with the leading coefficient of g. And now you just need two numbers that multiply to give you 18, but add to negative 11. Okay, what'd you get?
2 and 9.
2 and 9. Now be very careful when you say 2 and 9. Do you mean that they're both positive?
No.
Very good. Both would be negative, because then the negative 2 and the negative 9 multiplied gives you that positive 8, and added together gives you the negative 11. Very good. So again, I just come over here, parentheses g minus 2, g minus 9, and hit submit. And we did it. Great. We're up to 49. All right. So let's see. Let's just do one more in the challenge zone when we get up to 90s. Make sure that we got this. And then we're going to talk about, yeah, so let's do one. That's no harder. So well, could you come up with that pretty quickly? Because this one might be, a lot of students forget to do the most simple factors of that last number. So what would be the two numbers that, again, we want it to, whoops, multiply to give you negative 11, but add to give you negative 10.
1 and negative 1.
Yeah, very good. Excellent. 1 and negative 11. So again, we can do the plus 1 first if we want, or we could do the minus 11 first. It doesn't really matter which one we do. All right, so now let's look at, I'm going to clear this, the one where we did factor by grouping. Before we do that, I want to make sure we can remember how to solve factor by grouping. Where are we at? Where are we at? Numbers, exponents, polynomials, right here, factor by grouping. Let's do a few of these as a lead-in to factor by grouping. Now, so when we do this, you'll want to be very, very careful. Now, when we factor by grouping, remember to always look to group the first two things together. So what I mean by that is I'm just going to look at these two leading terms and say, what's in common with the 16 and the 8? What's the largest factor that they have in common? Greatest common factor between 16 and 8. Yeah, very good. So again, we're looking for the greatest. I'm trying to write things out as I go along. Common factor, if you remember that from a few grades ago in elementary, you learn it, greatest common factor. So in other words, yeah, we have an 8. So what I'm going to do is I'm going to write an 8. And then what's also in common, how many q's do these two terms have in common? Yeah, q squared. So we're going to factor out an 8q squared. Then what we do is once we factor that out, we're going to say, okay, let's divide this first term by that 8. So what's 16 divided by 8? 2. And when I divide the q cubed by a q squared, it leaves how many q's? 1. So we have a 2q for the first term. And then when I divide 8q squared by an 8q squared, a lot of students forget this. What happens when we divide this term by itself? Yes, you always are left with at least 1. Now this happens to be a minus 1, so we put a minus 1. Now the next step is we're going to look at those second two terms. So now I'm going to actually just put parentheses here and say, all right, let's see what's in common with these two, the greatest common factor. Now, a lot of times with these greatest common factors, sometimes it's a 1. And so you always want to factor something out. For instance, this last term is only 1. So the greatest thing they have in common is 1. So let's actually factor out a 1. So what I'm going to do is I'm going to put a plus 1 here that I'm factoring away or in front of the parentheses out here in front. So when I factor out the 1, I'm just left with exactly what I have, that 2q minus 1. 2q minus 1. So always do factor something out, even if it's a 1. So now what I want you to notice, though, is that this set of parentheses here and this set of parentheses is exactly the same. We have a 2q minus 1 and a 2q minus 1. So what we're going to do is factor it away from the 8q squared and the plus 1. So what we do is we pull that kind of like out in front as a single parentheses. So when I go to here now, what I'm going to type in is a single parentheses. We have a 2q minus 1. And that's going to actually be both of these pulled out as a single one. And then what's left, which is that 8q squared, 8q squared, whoops, squared, plus this 1 here, plus 1. Did that make sense? And then we hit submit, and yay, we got it right. All right, so let's do one more. And then we'll go into factoring the quadratics this way by grouping. So again, the first thing we're going to do is we're going to look to see what's in common with these first two terms. So what's in common with the 10r cubed and the 20r squared? Yep, a 10. And how many r's? Very good, 10r squared. So what's left of the first term? Very good, just an r. Plus, what's left of this second term? Careful. Yeah, 2. 20 divided by 10 is a 2. So we're left with a 2. All the r's are factored out. Now again, we're going to look at the second two terms. Now I'm going to just underline this. Just be careful, I have a negative on both of them. So I'm going to factor out a negative plus whatever else is in common with them. So what's in common with the 7r and the 14? Excellent. So I factor out a 7. What's left of the first term of those last two? Yep, the r. And what's left of the 14? Very good. Now again, you'll always know you've done this right if those parentheses look exactly the same, and they do. And that's important they look the same. If they don't look exactly the same, you can't factor it out as a single parentheses in front of those two leading 10r squared and the minus 7. So when we go to type it in, again, we factor out, and it really wouldn't matter if you put it in front or behind. So I could technically do the 10r squared first, but usually I just do the r plus 2. So I remember that was my first set of parentheses. And then what's outside or what's left is that 10r squared minus 7. Oh, sorry. Yes, I'm glad you said something there. That should be a plus because I factored out the minus sign as well. I factored out a minus 7. So I really divided this by minus 7. So that should be a plus. Yes, see, those two didn't look exactly the same. I shouldn't have been able to factor it out, except I made a mistake, and that should be, whoops, come on, where's a plus? Did that answer your question? Yeah, that should have been a plus. I messed up and left it a minus sign. I forgot that I was dividing out a negative 7, which makes that a plus. All right. So let's now use this process of factoring by grouping. Let's make sure we did it right. Hey, look at that. We did it right. It moved up. To factor by grouping on quadratics with a leading coefficient larger than 1 with other leading coefficients. Okay. So here we go. Now, do you remember how we went about doing this yesterday? Yep, you have to split the one, but how do you figure out how to split it?
You have to multiply the number on the right by the number on the left.
Excellent. Very good. So we multiply. So I'm going to grab this so Nelson can see when he watches. I'm going to multiply the first number, the number on the left. Welcome. There's paper and pencils and calculators and by the number on the right. So we're going to multiply those two together, which gives us 9. Now what I want to do is I want to find two factors of 9 that multiply to give you 9, but add to give you 10. So what are those two numbers? Yeah, 1 and 9. A lot of students forget the simple 1 in itself, the 1 number itself. So what we're going to do, that's how we're going to break this up. We're going to break this 10x into a 1x and a 9x. Don't forget the x's. So what I'm going to do is I'm going to break this into 2 terms. So I'm going to write the first term, that 3x squared. And then I'm going to break that 10x. And it doesn't matter which you do first. You can do the 1x or you can do the 9x. So I'm just going to do the x, or 1x. I just didn't write the 1x. And then I'm going to do the 9x. And then I'm going to write that last term of plus 3. So again, to reiterate, all I did was I broke this middle term into these 2 terms here. Now we do what we were doing in that last couple problems. We factor by grouping. So first thing I'm going to do is I'm going to look at these first 2 terms and say what's in common with these first 2 terms. There's only one thing in common I can see with them. Just the x. That is correct. So I'm going to factor out an x, which leaves what? When I divide this by x, it leaves what? This first term? Yep. 3x. And then when I divide this second term by this x, or factor it out, what's left? Very good, 1. Now I'm going to look at these second 2 terms and say what's in common with the 9x and the 3. Very good, 3. And it's a positive 3, so I'm going to factor out a plus 3. And then when I divide the 9x by 3, what do I get? Very good, 3x. And then when I divide this 3 by 3, I get 1. And again, I'm going to make sure that I've done everything correctly this time. I'm going to look at these set of parentheses and make sure they look exactly the same. I have the 3x, I have a plus and a plus this time, and a 1 and a 1. So since they look the same, I'm going to pull it out front as a single set of parentheses, which leaves these 2 in the second set of parentheses, right? So I can come up here now, type in my parentheses 3x plus 1, and then my second set of parentheses is x plus 3. And let's see how we did. Super, all right. So I want you to try this one completely on your own. Oops. So try this 6n squared plus 11n plus 3. And give you a minute to work on that, and then we'll see if you 2 get the same answer. Now, Brianna, if you need a little help, because you came in a little, because you need to break that 11n into 2 different numbers. We just need to figure out what's the right 2 numbers to break it into. Okay. All right. So what'd you get, Brock?
2n plus 3.
2n plus 3 and then 3n plus 1. Very good. So let's make sure we all did it right. 2n plus 3 and 3n plus 1. And we hit submit. Oops, submit's over here. And great job. All right, I'm going to jump up a little bit, see if we can get one that's maybe, oops. Ooh, yeah, let's try this one. Make sure, and you might, if you can use a calculator, by all means. So if the calculator doesn't work, because some of those calculators are battery. Yeah, this is going to be a big number, obviously. And then being a big number, it's going to be hard to find the right two numbers to use that add to 16. You finished, Brianna, or just struggling? Okay. How about you, Brock? Okay. Let me show you how I go about doing this. There's a very systematic way to find the right two numbers. My first question is, I want to make sure that you knew what number to use. So what number are you trying to break up? I mean, you're trying to break up the negative 16, but what's the product number you're trying to break up? Very good, 336. Sorry, what? And it is negative. You are correct. It is negative, yes. So yes, so when we multiply this first number by this last number, we get a negative 336. Okay, now this is how my systematic way of doing things. I know I got that by 84 and 4, but I know those two numbers don't give me negative 16. So what I do is I start moving factors from this one to this one. So what I mean by that is I can move a factor of 2 over to here, which means I'm going to do an 8 and a 42. Now, before I go further, I want to make sure you understand what I did. I divided this by 2, right? Because this is 2, that's very small. 2 times 42. Do you agree that 2 times 42 is 40 or 84? And what I did is I pulled that 2 and put it over here instead. So I still have all the same factors in the 336. And if you want to verify, you can always do 8 times 42s and make sure you get the 336. Now, since I'm looking for a negative middle number, I'm going to make the larger number negative. Well, that still doesn't give me negative 16, does it? So what I'm going to do is I'm going to bring another 2, right? I'm going to factor out a 2 from this. That's going to give me a negative 21. And if I bring that 2 over here, that's going to give me a 16. So again, I know that 16 times negative 21 is a negative 336 because I have the exact same factors. You see how I'm adjusting those numbers? Now, again, that still didn't work. So I'm like, all right, I'm still not quite there. But the problem is now I'm too, see here I was too big of a negative number, right? I had negative 24, I think. Here I only have negative 5, which is too small. So what I need to do is I need to make this number bigger and this number smaller, but only by a little bit. So do you agree that 21 is 3 times 7 and 16 is 2 times 8, right? What I'm going to do is I'm going to swap these two. I'm going to bring the 3 over here and the 2 over there and see what happens. Again, it's just a systematic way of trying to do things. So again, if I bring the 3 over here, so I have this 8 times the 3, that's going to be 24. And the 2 now comes over here with the 7, that's going to be 14. Again, I'm going to make the larger one negative because I want that middle number to be a negative 16. That gives me a negative 10. So I'm still not quite there. But I'm going to do one last thing. Since I really wish this number was a little bit smaller and this number was a little bit bigger, I'm going to bring a factor of 2. So I'm going to drop this by a factor of 2. That's going to be 12. And bring the factor of 2 over here. Does that make sense what I've done? In other words, 24 is 2 times 12, right? And 14 is, I'm just leaving the 14. I'm just bringing the 2 over, leaving the 12. But now look, what happens when I add those two together? Ah, it's negative 16. And so without using a calculator, I was able to juggle around the factors in 336 till I finally found the right one. Now, again, you can always do 1 and 336, 2 and that number, 3, 4, and work your way down. That just, I find it quicker to start moving these little factors around. So I haven't actually solved the whole problem for you. I've just told you what to break this up into. So can you finish it from there? So you're going to break that negative 16m into a 12m and a negative 28m, and then factor by grouping. You're done too? Good. So what was your final solution?
Oh, wait,
Oh, that's not what I wanted to do. Go back. So it's, well, what's in common with the first two terms? We got a 4m, right? So I like the 4m, right? I want to make sure I still have mine. So we had the 4m, and then when we factor out the 4m from the first two terms, it leaves, I think you said an m plus 3. Very good. Aren't they both plus, I think?
Oh, wait.
And then this one here, though, we are going to factor out a negative. Oh, from this? Oh, wait, from here? But when you factor by grouping, you got to make sure your two sets of parentheses are the same. Did that give you the same set of parentheses? Oh, then you reduced it again. No. So, no, because you're factoring out a minus sign, right? And you're going to factor out the 28, I believe, right? Because 28, I think, goes into 84 3 times, right? Yeah, positive 3 times. So this is going to be an m plus 3. And yeah, Brianne, if you factor out enough, and you said you factored out a 4 and then you factored out a 7, which is fine. And 4 times 7 is this 28, right? And so you actually write it as a 28. And then we can actually bring out the, write it as a 4m minus 28 in parentheses times an m plus 3. Now, they're being a little bit tricky here. We're not quite done. And the reason they're being tricky is, what do you notice about this number here and this number here? Yeah, they both have a factor of what? 4. So your final solution is going to have a 4 sitting on the outside of both of these parentheses, where this becomes an n minus 7. So in other words, I'm going to factor out a 4, which makes this a 1, or goes away. It's a 1. And this becomes a 7. Yeah, so in other words, the final factored form is actually even going to be a little bit, whoops, I want to do eraser, a little bit more factored because we have that 4. So when I type in my final answer, you're going to have a 4 on the outside of both sets of parentheses. Then you're going to have that m minus 1. No, sorry, minus 7, not 1. That's a 7. I made that really scribbly right here. M minus 7. And then that m, is it minus 7 or plus 7? M minus 7, and then m plus 3. Oops. Did that make sense, though, that one extra step at the end?
Yeah.
That there was that extra factor of 4 in there. Excellent. All right, so let's see if we can get one more, and then we'll maybe do something different. Okay, here's another good one. Let me clear all that extra stuff in the way. So let's have you do that one. Finished? Excellent. Okay, so Brianna, how did you split up your 27? So don't give me the final answer, just how did you split up the 27? Very good, right? Because the 5 times the 10 is 50, and the 25 times 2 would give you 50 still, and when you add those, you get the 27. So yeah, you should have split that middle term. This is the first term, plus 25y. Did that help you, Brock, get the final? And well, actually, that would be fine. That will still work. So yeah, if you wrote it as 5y squared plus 2y plus 25y, and I'll show you that it still works the same. You get the same answer. It works nicer than you think, but yeah, it's not as nicely, I agree. Because if we did it with the 25 in front, what's in common with these two first terms? Yeah, 5y. So we get a 5y, and then what's left of the first term? Yep, y is left of the first, and then a plus 5. And then what's in common with these last two? Yep, a 2. Which leaves a what? A y plus 5, which gives us the exact same 2 sets of parentheses, which is what we want. So we can factor out the y plus 5, leaving a 5y plus 2. But now let me show you that it would get the exact same answer if we did the other one in front, like you started out, Brock. The only thing in common with these two terms is there's no number in common, it's just the y, right? So if I did do the 2y first, I'd factor out just a single y, which would leave a 5y plus 2. And now what's in common with these last two terms? A 5. So I'd factor out a plus 5, which would leave a 5y plus 2, which again, those sets of parentheses are exactly the same. They're both 5y plus 2. So when I factor that away, it leaves the y plus 5. Well, here, that's where I got the y plus 5. You see how it ends up being exactly the same thing? Because on this bottom one, you just have the 5y plus 2 in front. So what I'm doing is I'm factoring out this and this away from the y plus 5. Where on the top one, if I change back to blue, or to red, I guess, this one up here, I'd factor out the y plus 5. Which would leave this 5y plus 2. So it's exactly the same, it flops the order of the 2 sets of parentheses, but it gives you the exact same answer. So yeah, so don't feel like you have to have the 5y in front. It doesn't really matter the order. And when you type it in up here, it doesn't really matter the order you type it in. I could type in either one. I could type in the 5y plus 2 first. Make sure you do parentheses though. And then the y plus 5. Or I could do the y plus 5 first. Excellent. Any questions on that? Do you feel comfortable doing those? Okay. All right. So let's move on to something a little different. If you can, by the way, if you can do that as far as factoring quadratics, I think you'll be fairly ready for whatever they throw at you next year for quadratics. They just want you to be able to factor the basics. By the way, do you remember what a quadratic looks like? If you graph it, what the graph looks like? Yeah, it's a U-shaped. And just realize that those U-shapes can be up and upside down. So let's show you. I want you to be familiar with the graph. I can easily go to, where are we at? This here. Actually, let's clear out all that drawing. Let's hopefully, yeah. The interesting thing about this graph is I can't make the graph itself bigger. I wished I could like zoom in and make the thing bigger, but yeah, so here's an equation, y equals, and it doesn't even matter what it is, 2x squared plus 3x minus 4, whatever it is. And I zoom out a little bit, you'll be able to see that it's just kind of a U-shaped, right? Comes down like this and goes back up, right? Then what would make it upside down is if I put a minus sign in front of the x squared term, then I don't have to change anything else. I'm just changing it so it puts it up higher, but that flips it upside down. And that's how you know if to use upside down or right side up, by the way. It's that leading term. I'm not sure. I wished I could make that bigger so you could see it from the back of the room, but I can't. It won't. No matter what I do, I can make the graph get bigger in a sense. I can click on it. Anyway, I can enlarge the graph, zoom in on the graph, but I can't zoom in on the equation, which is weird. But yeah, so just remember if the x squared, don't save, if the, like this one would be opened up because that's positive, but if this leading term was negative, then it would be upside down. And so get the feel for what they are. All right. Excellent. Let's in fact, actually, here's some graphing transformation, graph quadratic function. You don't need to go into all that. Let's make sure you remember those special cases of factoring. Like for instance, I just want to make, because you'll see this. One thing you always need to look for in quadratics, if there's two terms, not three, ask yourself this question. Is 9 a perfect square? And what do I mean by a perfect square? Is it 4, 9, 16, 25, 36, 49? What are all those numbers? They're like 9, what's the square root of 9? 3. What's the square root of 1? 1. This is called the difference of two squares. Since it's the difference of two squares, the middle term is 0. So again, what we're going to do is you just think about, okay, I have the square root of 9 is 3. The square root of k squared is k. And then the square root of 1 is 1. And then I type that in twice, except you make 1 positive, a plus, and 1 a minus sign. It's called the difference, because that's subtraction, difference of two squares. And so this here is actually the sum of two squares. And what I mean by sum, it's what's the square root of 9? What's the square root of 4? What's 3 times 2? And what's 6 doubled? 12. So yeah, so a lot of times if you see that this leading number is a perfect square and this n number is a perfect square, you can just square root them. But this time, instead of doing 1 plus 1 minus, you do them both plus. And the reason you do, 3v, because the 2 times the 2 gives you the 4, those two n terms. The two first terms, 3v times 3v gives you the 3v squared. And your two middle terms, that 3v times the 2 is a 6v, and you get 2 of them, and 2 6v's add up to 12v. You remember foiling last time when I had you? I mean, I don't think you were here for that, Brianna. Maybe we should do one of those where I had you go the other direction. What I had you do is I had you do this. So let's have us do a couple of these. Make sure that Brock remembers how, and Nelson. Could you multiply those two things together? You remember the FOIL method, distributing? Yeah, where you take the first term. Yep, exactly. Yeah, first times first, first times last, or that's the outer. last times first, or the inner, and then the last times the last. So you get those three terms. You would get a 2g squared. That's the first times this g. And then the first times the last would be a negative 4g. And then the last times the first would be a negative 2g. And then the last, that negative 2 times the negative 2 is a plus 4. And what we get is we always get these two middle terms that add together. They're like terms, and negative 4g minus 2 more is negative 6. So your final answer would be just a, whoops, gotta go back here. It would just be that 2g squared minus 6g plus 4. And what I was doing on those ones was the difference of two squares is sometimes those middle terms cancel out. Because that's all we're doing on these is going backwards. So we're going backwards. So again, you look, you see 25, that's a perfect square. You see 9, that's a perfect square. By the way, it's not always true, but in general, you could try that sum of two squares or something where you go the 5 is the square root of 25, and then you have a v, the square root of 9 is 3. And then in my head, I just ask myself very quickly, the two middle terms, 5 times 3 is 15, and you get another 3 times 5 is 15, and what's 15 plus 15? 30, that middle term. So it's the sum of two squares. And then this one is the difference. And that's because those two middle terms cancel out, right? You'd have an s minus 4 and an s plus 4, s plus 4. And think about what the two middle terms would be. If I was to actually do that, multiply those back together, s times s is s squared. S times the positive 4 is a plus 4s. And then the negative 4 times the s is a negative 4s. And what happens to those two middle terms? They just cancel. They go away. That's why there's no middle term when it's the difference of two squares. And then the negative 4 times the positive 4 is the minus 16. So those two middle terms. And that's all we're doing is factoring backwards. Good?